This shaded area looks difficult, but the most interesting thing is that it can be solved in two different ways. The question is, which one would you see first? Before we solve it, pause the video and try to figure it out on your own. Then let me know in the comments. I'll show you both different ways we can solve it. Shall we go to the board? Here, look, the problem says the following. In the figure below, the highlighted angles are right angles. Knowing that the indicated lengths are 4, 7, 10, and 13 centimeters, determine the area of the shaded region. The shaded region is this shaded region here, all right? I'm going to clear the board here so we can organize things better to solve it, and I'll show you two different ways. Well, the first way for us to solve this problem is as follows. Taking this shaded area, right, the highlighted area, and dividing it into two shapes. Which shapes are these? These are a rectangle with sides 7 and 4, which is this red rectangle, and this yellow triangle, for which we already have the side of the triangle, which is 7. It's the same side as the top of the rectangle. So I'll leave this here on the side. Look, well, the rectangle is easy for us to find the area. It's side times side, and we already have both sides of the rectangle. Now, for the triangle, we only have the side, which is the base of the triangle, measuring 7 centimeters. Now, pay attention. Since the area of the triangle is base times height divided by 2, we still need to find the height of the triangle, which I marked in blue here. Now, think with me for a moment. Since we have to calculate this blue distance, which is the height of the triangle, if we look closely, this distance, this measurement, is exactly the same as this measurement here. Look. And by drawing a line parallel to this baseline at this point here, we form two shapes, a triangle and a rectangle. Now I see the following. The measurement of the lower base, the bottom base, is 13 centimeters. And the measurement of the upper base up there is 7 centimeters. Consequently, this distance here is also 7 centimeters. Well, if the measurement of the lower base has a total length of 13 centimeters and we already have 7, how much is missing to complete the 13 centimeters? It's missing 6, right? 7 plus 6 equals 13. So this distance here, this measurement, is equal to 6 centimeters. Down here it's 6, so up here it's also 6. Now in this triangle, we already have one leg and the hypotenuse. We want to find the measure of the other leg, which I'll represent as x. We just need to use the Pythagorean theorem, right? The square of the hypotenuse is equal to the sum of the squares of the legs. The hypotenuse is 10, one leg is 6, and the other leg is x. So we get 10 squared equals x squared plus 6 squared. Solving it, look, 10 to the 10 squared is 10 times 10, which is 100. Now 6 to the 6 squared is 36. I move it to the other side, subtracting minus 36, and that's equal to x to the x2. 100 minus 36 is 64. So it will be x to the x2 equals 64. Moving the exponent to the other side as a square root, x will be equal to the square root of 64. The square root of 64 is 8. We conclude that x is equal to 8. We found the other leg of the right triangle, so let's substitute x with 8 there, okay? Well, if this side of the rectangle is 4 centimeters, this side here is also 4 centimeters. With that, we can find the measurement we were looking for, right? 8 plus 4 is 12. So this side of the triangle here is equal to 12, okay? I'll write it here, look. Now that we already have the two sides of the rectangle and the two sides of the triangle, which are the base and the height, we can calculate the areas. And then we add these two areas and we'll find the shaded area, okay? Starting with the rectangle, its area is base times height. So the area will be 4 times 7, which is 28 square centimeters, okay? Easy. Now the area of the triangle is base times height divided by 2. The base is 7 and the height is 12. So the area will be 7 times 12 divided by 2. 7 times 12 is 84. 84 divided by 2, the area will be equal to 42 square centimeters. Now that we have the area of the rectangle and the area of the triangle, we just need to add these two areas. I'll clear some space here so we can work it out down below. The shaded area will be equal to the area of the rectangle, which is 28, plus the area of the triangle, which is 42. Solving this addition, the shaded area will be equal to 28 plus 4270 square centimeters. Whoever chose letter C got it right. That's the answer to the question. Well, this is the first way I showed you to solve it, by finding those two areas there of the rectangle and the triangle. Now I'm going to show you another way to solve it. In this second way to solve this problem, we will first find this side here of the figure. Next, we'll find the total area of this figure, which is a trapezoid. What do you mean, Professor, a trapezoid? Relax, take it easy right now. Remember that we drew a line here, see? We drew this line and divided it here into two figures, a triangle and a rectangle. If the bottom base is 13 and the top base is 7, then this distance here is also 7, just like we saw in the first way to solve it. Since the total distance of the bottom base is 13 and we already have 7 centimeters, we need 6 more centimeters to complete the whole distance. 6 plus 7 equals 13. If the bottom of this rectangle is 6, then the top is also 6, just like we did in the first way to solve it. With this, we have a right triangle where one leg is 6 and the hypotenuse is 10. Solving it using the Pythagorean theorem, we will find the other leg, which is equal to 8. This triangle is a Pythagorean triangle. Every time one leg is 6 and the other leg is 8, consequently, the hypotenuse will be 10. In the same way, the triangle 3, 4, and 5. 5. If one leg is 3 and the other is 4, the hypotenuse will be 5. It's the famous Pythagorean triangle. Well now, looking at this rectangle, if this side of the rectangle is 4, this side here will also be 4. With that, we found this measurement here. Look, 4 plus 8 plus 4, which equals 16. If this side here is 16, this other side here is also 16. Now we already have the measurements of this figure here. Remember that I told you this figure was a trapezoid? This is a trapezoid where the longer base is 16, the shorter base is 4, and the height is 7. What do you mean by that? Well, this trapezoid is on its side, right? If we set it up right here, look. See that the longer base is 16, the shorter base is 4, and the height is 7. To calculate the area of the trapezoid, it's base plus base times the height divided by 2. Where b is the longer base, b is the shorter base, and h is the height. Substituting the values we have, the area will be b, which is the longer base, 16 plus b, which is the shorter base, which is 4 times the height, which is 7, all of that divided by 2. 16 plus 4 is 20. 20 times 7 is 140, so it will be 140 divided by 2, and 140 divided by 2 is equal to 70 square centimeters. See, it's the same answer we found in the first way we solved it. Who chose letter C? Mark the question as correct. Now tell me, had you seen both solutions or just one of them? Leave it in the comments. And for you to keep learning math in a simple and strategic way, don't forget to subscribe to the channel and leave a like to help the channel grow. Share it on social media with your friends, all right? Big hug from Professor Robson Lyers, Mathematicamente. I hope to see you in the next class.